It says live. Life is live.
It's all alive.
Well, welcome to the Big Bang. Yeah, let us show what we mean by the Big Bang. I hope everyone can see this video, and it is quite impressive. Jameson, did you see it? Is it live?
Yes, it's live now. Yes, it's live now.
Okay, the Big Bang, not just the theory. Yeah, okay, just a little joke at the beginning, and welcome everyone to our new webinar. First webinar in August. And I must say, hello, Jameson.
Yes, it must be a hot, sunny holiday season in Europe.
Oh yeah, actually it is. Actually, it is. I must admit the weather here in Frankfurt at the moment is super nice. We have like 20 plus something degree during the day, and in the evening it is going to be 20 around. So it's just great. We really have a very nice weather situation, which is actually not the case in all areas in Europe, because you might have heard this close to the Mediterranean Sea. There's a lot of fires at the moment.
Yeah, in Greece, I think. I thought the last time I saw was in Greece.
Right. Yeah, Greece and other areas. I heard in Tunis, is that right? Hopefully it is right. There was more than 50 degrees C yesterday. Crazy temperatures. So we have a very, very hot season here. And I heard that in Greece, they even had to, they have problems with the electricity because it's coming to its limit, and because of the high air condition consumption, power consumption. Yeah, there's some problems there.
In fact, in our news that was 2 days ago, it was a big news on the first page saying that the climate change is at red alert. The red alert.
Yeah, I don't know. I mean, I think sometimes people react too fast. I mean, the climate change is happening. There is no doubt about that. But you know, sometimes you have a hot summer and sometimes you have not such a hot summer. But I think really with, you know, the flood we had in Germany, which is still such a big topic and such a big pain for all the people in these regions. And now with a fire situation at the same time, I think we can see the impact on the climate. So, yeah. I still believe we have an important role here.
We have,
honestly. I mean, our task. I had some recently. I had some interviews, and you know, it's, I would say, kind of interesting when you talk to the people and they think, okay, yeah, this is some technical equipment and it's well done and it looks good, but what is all of this about? And I think it's, maybe I'm also a little bit proud that, you know, we, in our measurement, with our components, with the sample handling, I mean, it's not just us, but also our competitors, our partners, you know, we do a very good job and we work very hard every day to deliver the best solution and to make sure that the analysis and the measurement of emissions, which will still be there, are on a super high level, right?
That's true. That's true.
So yeah, but Jameson, our vice president from Singapore, how is everything on your side?
Oh, I think we just had a report of our economy. It was a turnaround, an upturn this quarter, a big upturn of 17% plus. Wow. Because it was down all the way, so it's very easy to have 70%.
Yeah, I think that the numbers at this time is a little complicated, because we should compare 2019. That was the normal. I mean, that was a relatively good year, but we should compare these numbers. We have the same, you know, when we look at some areas and you think, wow, this is tremendous growth, and then you say, yeah, but Let's compare it. But anyway, you are healthy, you're okay. But the news from your region is Southeast Asia, even China, I think, is again on a very strict lockdown, right?
Yeah. That's definitely, yeah. Especially this place called the near the Nanjing area. Yeah.
Right.
The province known as Jiangsu, province near Jiangsu. Jiangsu, the capital of Jiangsu is Nanjing. It was the source of the delta.
In China, I think, yeah. Okay, yeah. Oh, but Jensen, now this is the first webinar since I feel since quite a long time that it's just us. I mean, it is not just us. I thought more than 300 people signed up, and I mean, come on, we are in a holiday season. I thought, hey, I mean, we were discussing, do we make a summer break or will we continue? And then we said, hey, let's take some of our topics and we will continue. Yeah, and now more than 300 people signed up. I'm again overwhelmed. But Jensen, we have to discuss what happens there in the month of July. Crazy. I mean, we saw numbers, and I must admit, I really enjoyed all of them. Starting with ABB, I think this presentation was just, great, and showing different aspects. The guys, the experts from Siemens, wow, with the GC background. And then I also think the INVEA webinar we had was, I'm always impressed about let's say the richness of the solutions and the experience these companies have. It's wow.
Yeah,
it's impressive, right?
Yeah, in fact, the feedback is that very early when they enters into the webinar, they were probably, it's like very naturally they feel a bit nervous. But towards the end, they find that the time is too short. They wanted more, a lot
more. That's true. That's been a big fight, right? That's been a big fight. Yeah. No, but I must really admit, I mean, we can see all these numbers, and I want to thank the companies. I think it was just, even for us, sitting there, understanding their philosophies, seeing their solutions, this was super impressive. And I must also admit, I mean, these guys, they opened for us.
Yeah, I learned so much from them.
Yeah, no, and I mean, they gave us some insights. Look at INVEA, where they gave us a picture. Okay, how are they going to show and how are they going to integrate the sample handling system into their analyzer system? Siemens shared some very, I would say, special information regarding a real use case, which was impressive, and also ABB. So yeah, I'm super happy that we could convince these guys, and I'm also very happy that the tour continues. So but we had to spend this 10 minutes here at the beginning, really to review what happened. And I think it also, it's a strong situation that we will have some new webinars coming up. The Meet the Experts will continue. So I've forgotten to say hello to everyone. I think we said hello, and as usual, wherever you watch us, just leave us a very short message. Just leave us a very short comment. And also today's topic, CEM system design and configuration. I think we put a lot of information together. If you have any questions, let me really say that. I mean, we live from your feedback, and we can only improve if we have your feedback. So please be so kind. Just leave us a short comment wherever you are. Say hello to the world, and any questions, any problems, any issues, just let us know. Okay, Jemson, now I think we have to speed up, otherwise we run into the same problem our dear colleagues from ABB, Siemens, and NVIDIA had, running out of time.
they run into so much enthusiasm.
Yeah. Yeah, and I think partly we were also responsible for this because I was so interested in many of these things. So I found myself, okay, I should ask this question. And then the guys were, answering this in a very extended way, which was just great. And then finally, we had to be the bad timekeeper. But anyway, okay, Jemson.
Yeah.
Can you show the next slide, please? Then, all right. Like I said, our tour is going to continue. Our Meet the Expert tour is going to continue. After having ABB, Siemens, and NVIDIA on board in July, we were thinking, okay, what is additional topics which might be relevant and interesting for the people who watch this on a so regular base? And what we would like to do here is, I would say, something special. I mean, there is a very big name in the field of analyzer coming up, which will be SICK. We will be hosting, and I'm very proud that we managed to get these guys on board. We will be hosting the SICK webinar at, I think it's 21st of October. And they would show us not just the sampling or the components. I think they will also show us their capabilities in the field of systems. So I'm pretty sure that's going to be very special, and they will share some very special information. These are the analyzer guys. I mean, we got this feedback, and that was initially the idea why we started to Meet the Experts, is inviting the analyzer guys. So showing we have the sample handling system on the one side, but I think, and this is something all of them confirmed, only if there's a perfect harmony, only if the sample handling and the analyzer system is synchronized, there will be a good result, right?
Absolutely.
Yeah. I think this is something all of them agreed on. But what we would like to do too is we would like to give some insights. What are the partner companies we are talking to, or we are working together, we do have a cooperation with? And therefore, let me just start with one topic. As you can see the overview here, there is a logo of a company called Henkel Electropolishing Solutions, and a company called Silcotech. Now, it could be from wherever you watch us that these two brand names do not sound too familiar with you. But I would like to show you, I mean, we will talk about the heated sample lines and also the inside of the heated sample lines. I mean, we have two main components. The one component is, Jemson, can you see that? Is it fine?
Yes.
Yeah. We have the stainless steel tube, right? And the stainless steel tube here, in certain measurements, the surface of the stainless or of the tube inside the heated sample line can represent the longest surface of the entire sample handling system. I think I say that in the video I'm going to show shortly. But now there's certain ways what you can do in order to treat this surface of the process or the probe tube. And therefore, I'm very happy at in September, I'm very happy to have Henkel, the experts in electropolishing, and Silcotech, the expert in sulfinet covering, So, and I'm very excited to have these guys on board so that they can show us, Jens, what is the different technologies? What is something you can do if you have problems with, for example, memory effects?
That's right. Yeah.
In order to tease that, let me just shortly show you one video we produced together with a company. Henkel. Hello. Today we take a deeper look into our heated sample lines, and inside of the heated sample lines we look at the probe or process tube. Especially when the heated sample line is very long, the probe tube and its surface can represent the biggest surface inside the entire analyzer system. Now, there's very special treatments which I'm proud to hand over to real experts in this field, the company Henkel. Benedict, how does that really work?
Well, Jörg, thank you for your question. Electropolishing is a surface treatment process also applicable for tubes in endless dimensions like this 316L stainless steel coil tubing. Electropolishing leads to surface smoothing like this animation nicely shows. Surface roughness will be reduced and surface properties will be improved by electropolishing. In summary, you can say that electropolished stainless steel surfaces are a better calculable product contact surface for a wide range of industry applications, also for the probe tube in your heated sample line.
Thank you for this great explanation, and I'm very proud to announce this unique partnership in Europe. That's a good surprise, Jensen, right?
Unexpected.
I know, I haven't shown you in advance. No, yeah, this is something I'm very excited of because, I mean, so far, electropolishing in heated sample lines, in tubing bundles, is something you can only buy from the US. And I'm very glad and proud to have this partnership. But at the same time, we want to show what is different, you know, different treatments you can do on these tubes. And yeah, Benedict is a real expert, like I said, and I'm glad that he will join the webinar. And at the same time, Johannes Kütt from Silcotech company is also there, also a real expert. So I think that's going to be super exciting. Okay, next one is Thomas, Gardner, Denver, Thomas. These are the guys we're working with for our peristaltic pumps since super long. And I also think that this is going to be interesting information to get more details about this, I would say, very simple looking machine, or this is very simple looking pump, right? So I'm excited to have these guys on board. Then we managed to get KNF. I think super established, very strong brand, which will show us what can we do in the field of gas sampling pumps. I think a very important topic in our CEM system and in the design of it. Okay, and then we have next to SICK in October, we will have Raychem. It shows nVent, the brand, the main brand from nVent is Raychem, the Raychem heaters. I always say it's like the engine of a car in our heated sample lines, tubing bundles. And last but not least, the company Schramm. You might not have heard of them. You might have, depending where you are. But this is our partner for enclosures and analyzer container and boxes. And I'm also very excited to have these guys with us on board. Okay, Jemson, 20 minutes left and we have not even started. Now we really have to rush. Sometimes we receive messages from LinkedIn and other sources, and they say, hey, I missed the webinar. I missed the live version of the webinar. So what we did here is, when you visit our LinkedIn page, you always have the chance, but I'm not sure how long the live streams will be available there. In order to make sure that you have access to it, we updated our YouTube channel. So you can just go to YouTube and you will find the past webinars starting from now. So the webinars with ABB, with Siemens and NVIDIA, you can find there, and yeah, you can just easily see it there. So hopefully another, let's say, improvement for our customers and for the people who are interested in the webinars. Okay, so Jemson, this is the one for in 2 weeks, right?
Yeah, it will be next fortnight.
So what's the topic?
Yeah, the topic is to stay relevant to meet the fast-changing demand for ATEX requirement. So it is going to be a holistic new approach towards establishing to meet the new demand of ATEX. It's going to be a big surprise to many of the analyzer industry, all right, particularly on our heated line. So I would say, I'm going to promise you that those people have not seen in the past. I promise you that you're going to be an eye-opening, all right, about new ATEX products from us.
Yeah, let's eye-opening. That sounds really good. Yeah. No, but I'm also looking forward to it. We are clear. It's still August. It will be a smaller audience, but yeah, I think it's going to be very interesting to show our newest innovations there and our newest developments.
Yeah. I hope if there's any EPC, EPC main contractors to attend the webinar, there will be something that, wow, is that something like this that they have missed, in the past?
Yeah. To be honest, just in this week, a very big German company contacted us, and they were exactly searching for the solution we developed there. So. Yeah, I'm not allowed to tell the name, but it's going to be exciting.
Okay.
I think we will make sure that this promise will be true. Okay, right. Jemson, now we have to get started. Oh, 20 minutes.
Yeah. I think you're the CEO of the company. Now, give a brief background about our companies.
But I talk so much now. Okay.
but because this is a CEO, no one is better than yourself.
Yeah, no, company AGT-PSG, I think, it might be that we also have some new visitors here. So we are working in the field of sample handling systems and sample handling components. And therefore, we produce gas sampling probes, heated sample lines, and gas conditioning system. We always say to sample, to transport and condition the probe so that at the end, there will be a reliable, stable analyzer result. That's our mission. And that's how we try to put it together into these three words, the perfect sample gas and the perfect sample gas solution and system. So at the beginning of this sampling, because we want to touch here on not just theory, and I think Jemson will also share some very practical background on this. There we have this super long list, Jemson, and I think this list is not coming from theory, right? This is coming from your super long experience in the field of not just analyzer system, but also sample handling system and components. So and this is the reason why we started with a big bang. Why did we say the big bang? Let me just put it in here again. We said the big bang because this is the primary probe sampling. If something goes wrong in your sampling system, you have to handle, or in the primary probe sampling, when you take off the sample from the process, you have to handle later. And maybe this is a theory, but also very true in real projects. If you can make sure that in the primary probe sampling, you eliminate problems, you don't have to deal with this later. Jemsen, is that something you would confirm?
Yes, yes, yes. In fact, this is the most important thing that a lot of people, particularly those people who are new, the first installation of SAM systems, everybody do not want to go up to the stack just to change the filter element. So they expect it to have a kind of a blowback, auto cleaning, right? This is something that always got stuck. That why people choose a blowback, all right, and what kind of filter element and what porosity, right? Whether it's 0.3 micron or 3 micron or 10 micron. This is something I'd like to take this opportunity to clarify. So this is something
So again, we're talking about the gas sampling probe. I said the primary sampling equipment in SAM system. And Jemsen, maybe you can explain a little bit about what is inside and what is a blowback.
Yeah, this is the this is something I'd like to show to you that a sample probe is the only component that in extractive systems that is really exposed inside the process, and it is the first thing that do the filtration of particles. I mean, it is quite naturally people say that there is a blowback, that anything get clogged and then you have a blowback and it cleans up. Theoretically, this is correct, but not practical. It is not practical. All right. However, if you understand the design behind this, then you will understand what is really by means of back purge. Now, let's take a look at this filter.
So again, maybe for the people who are not that experienced, we have two probes there. We can see it's a PSG basic, and what you are now showing here is the PSG plus probe, right?
Yes.
And we are talking here about a measurement, a technology which allows to clean the probe by itself, right? So no one has to climb up and no one has to change the filter. So by using this back purging, it's capable to reduce the maintenance effort. But you have to explain us how that works with the filtration, James.
So now let's take a look at here.
Oh, you did some drawing.
Yeah, I deliberately make an effort to do some drawing.
Hey, Jemsen, wow.
Now,
I put you on the big screen.
No,
absolutely. Okay. Yeah. Great.
No, this is important. That making sure that you're able to see. Are you able to see it without the reflection?
It's okay. It's okay. It's a little reflection, but I think it's fine. Yeah.
Okay. Now, there are many probes there, and to have a back purge, it has to consider two things. First is the design of the sample probe. Number two is the secret of the filter element. So the next thing people ask that, am I going to use a 10 micron? Should I use a 3 micron or should I use a 0.3 micron? So people always have the information that if I have a 0.3 micron, which is so fine that isn't it easy to clog, easy to get blocked? The answer is reverse. It is no. Let me explain. From the ceramic filter point of view, you look at the ceramic filter. All right, it is very thick. It's very thick. And you can look at this ceramic filter. There is a white surface and a black surface. All right, so just imagine that if you have a 3 micron filter, all right, 3 micron, the particles, the black particles, will start, during continuous suction, the particles were able to go in through a 3 micron. Once it goes into a 3 micron filter, no matter how you back purge, you have difficulty of find a way out from the particles, which means if I were to if I draw this way, the 3 micron will eventually block the porosity that goes in. Whereas, if you look at for us, we are using a surface coating, which means, right, the micron, it is multiple layer. On the upper layer, we use a 0.3 micron. So unless the particles is smaller than 0.3, otherwise the particles is stay on top. We wanted to prevent the particle from entering into the filter element. All right. So once it did not goes in, when we have a back purge, you see the entire surface of this filter is not blocked. Push air strong enough to go through, and from here the back purge effectively. So if I were to draw this way, if you look at the layer, the filter layer, the upper layer is 0.3, the lower layer is 3 micron. So the particles here is bigger than 3 micron, but stays on top. They have no chance to go in. And when I have a back purge, right, the air will go through all the way, and then they just do a purge out, a flush out. All right, this is called a back purge. That many people has mistaken this because many times we don't have an opportunity to explain through a whiteboard. Therefore, you look at the design of the filter element. All right, it's a white color, and you can see that it's gray. Right inside is very dark. All right, meaning that we wanted the external lever, the layer here is 0.3. The particles is staying outside. When we do a back purge inside, all right, there's no chance for the particles to go in. All right, so it back purge. It comes out. This is something that I like to clarify to many people have these questions, but
thank you so much, Jemson. I think it's that's quite impressive to see. It just came into my mind. Can you share? I mean, we have in our presentation there is one slide in our standard presentation, Jemson, in the knowledge transfer presentation, where we show the animation of the back purging. Maybe this is something we can show here. You have it on your computer, or?
Yeah, I have to find it.
Yeah, no problem, Jemson, because there's also something I would like to show here. In the meantime, maybe you can search for this. So, but I think the interesting point here is if you look at the probe and the back purging, because sometimes we do get questions: why is the dimension, why is the tubing here so big? And this is something, we would like to share, because this is, it's maybe also one of the secrets why the back purging of this probe here is so efficient. This is really the size of and the dimension of the tubing for the back purging, right? This is really the big advantage. A movie which you saw at the beginning, or I think we have another presentation here where we are going to share this again. You can only produce with this dust. I think we can only produce if you have a strong and very efficient back purging. You found it, Jemson, or is it?
Yes, I'm ready. I'm ready.
Okay, can you share it? Yeah.
Yeah.
There we go. Yeah. Great.
Yeah. And this how it looks like. You can see that the ones with a bigger filter element that we have, right, which is in fact we have a 212 centimeter square, the very big surface, which is probably the biggest available in the market. Meaning that, as far as emission is concerned, all right, in entire world is always lesser or below 100 milligram, which means that, based on 100 milligram with this filter element, I guarantee you that you do not need to attend to the filter element after, as much as 2 years. All right, you can simply do a back purge. So now doing back purge, you look at the surface, how it goes. You can see the dust is coming in. The purpose is to block, is to prevent the particle from going in.
The particle, right?
Yeah. So because once it enters, there's no way the particle can come out.
Right.
Yeah. So when we execute a purge, all right, pressurized, it goes through the layer and the particles will actually pulse out.
Yeah. Okay, is there, Jimson, is the next slide the overview of the back purging?
Yeah, look at
yes.
this.
Ah, great. Yeah, that was the one I was looking for. Excellent. Yeah.
This is the this is a sample. The gas sampling is coming in. All right, it's coming in.
This is the normal mode. Yeah, this is the mode how it's operating. Yeah, and
but this is a secret whereby how the probe design is filtering from outside to inside. Yeah. Right. This is important. It's filtering from outside to inside. All right. When we do a purge, the purge, this test gas, okay, the purge that goes in is purging from inside to outside. All right. This is where, maybe it's just too fast for the audience, but this is important. You know, if they were to go back to the YouTube or when we load up the videos, they can see this one more time.
Absolutely. Yeah.
Yeah. So
okay, Jensen. Sorry, I think I I crashed your presentation. Now you have to switch again. But I think really we have to look at the time. Primary probe sampling, filtration, filter surface, back purging. That's what we covered. So this is there, like we said, if you manage to eliminate, to remove problems, particles, if you're not running into a situation of condensation, so the probe has to be perfectly heated. I think there's already a good chance that from the initial sampling to the transportation of the line, nothing should go wrong. Is this something you would confirm, Jimson?
Yes. In fact, given the time, I'd like to quickly move on to show you, the heated line. Yes,
that's what we are saying. So, and in other webinars, we always outlined, be careful, please, because any cold spot, and this is especially the connection from the probe to the heated sample line, any cold spot can cause problems.
I just want to add one point for the audience. That very cold spot between the heated sample probe and the heated line, at that moment of joining, that joint, if there is a cold spot, this is what you will face. The SO3, the acid of SO3, all right, they collectively form crystallization, and you will get a first blockage at that joint. All right, so just be careful. Please pass it back to you, York. So sorry.
No. That was excellent, and I think it was quite impressive when we talked to the analyzer guys. This is something they confirmed. I mean, it's a super high, super sensitive technology, and at the end, it comes down to condensate, which is caused by cold spots. So we cannot outline enough the importance of avoiding any condensation in your sample handling system. So overview, why do we have in the preparation for the video, for the electropolishing, I said again, we have more than 2,500 different heated sample lines. We developed and manufacture more than 2,500 different versions. And I mean, the question is, why so many? Why couldn't we standardize this? The reason is, depending on your application and depending on the requirement of the application, different technologies are needed. So on the one hand side, we have the flexible heated sample line. This is something you see here. I will make bigger, or you see on the left of the PowerPoint presentation. And then we have the so-called extruded heated sample lines. And all of the lines have special applications where they are needed and where they will be used. And at the end, Jemson, if you go to the next slide, please. I mean, the underestimated of this item is something we sometimes say, Jemson, but what did you want to add?
Yeah, This is a photo that I've taken, right, when I was at in one of the plant. These are the things that we discover, and these are the things that you can see that from the photo, right? You can see what really happened is that overlapping of this 3 heated line overlapping from there.
Wow.
Yeah, and you know, and when we look carefully, of course, I must clarify this doesn't belongs to us, but you know, this is something that I saw at the site, and
but actually, I mean, it could belong to us. We have, I mean, we have a good documentation, I think, mounting instructions, installation instructions, and all of this. And we always say, hey, be super careful. Do not cross it, because I mean, the heat is just going to exceed, and then at the end will cause big problems, right? So yeah, okay.
Yeah, and this photo was taken by me. In fact, you can look at, you know, when we talk about, when you say, you know, heated line, you always mention, you know, it is the most underestimated sampling component. Yeah, it is because this is a black hose. Nobody know really what's inside, you see. Mm-hmm. So this is another photo, all right, that I've taken at site. You look at the jacket and the exterior of this, you can see how badly it was designed and then constructed. You can see the skeleton and the bad insulation, the way they wrap it, you know, the way they're wrapping. And this is also taken at site, all right? In fact, what happened, because of the overlapping, the over temperature, it caused a fire, right? It burns out.
Yeah, but Jensen, we shouldn't be too fast in judging this situation, because I mean the situation on site itself can be complex. Maybe that's right. It could be that it's not that the insulation which was used was not right, or that maybe the heater itself started to burn. But I mean, depending on the heating technology you use, you have to use a temperature controller, and there could also be, let's say, human mistakes. You know, that setting up a too high temperature, like you said, overlapping. So this is nothing we would like to finger point to say, hey, we are the only ones who are delivering the perfect quality. But I mean, the message we clearly want to place here is, do not underestimate. Yeah, and look into this very careful, because at the end, this might make you more problems than you are currently expecting.
Mm-hmm. Mm-hmm. Yeah.
So, yeah. James, but let me just shortly show some details of the heated sample lines, just to give a little bit more detailed explanations, and allow me to outline also what is very important here. If we talk about the flexible lines, I mean, as you can see here, the insulation comes from a different technology. Here we have a thermal fleece, which is used for these type of lines. And the fixed resistant line comes with a silicon rubber insulation. And you can also see a big difference from the heating tape. Heating tape, meaning the electrical heater, which is responsible to heat up the heated sample line. And in this technology, in this flexible heated sample lines, it's often combined with a so-called fixed resistant heater. Means there's a certain power output designed on the length of the line. Advantage is it is wrapped around, so there's a lot of power you can bring in this type of lines. 90 watts, even 120 watts per meter is possible. So there's a lot of power. At the same time, the problem, or let's say the disadvantage, is you cannot cut to lengths. So this line cannot be cut. This technology here with the extruded heated sample lines, especially in CEM systems, which are, at least in Europe, in the most configurations operated at 180 degrees C holding temperature. So this type of lines, we have high developed technology. Here, first of all, we have two different type of heaters. parallel heaters. The heater is parallel to the probe tube, and at the same time they have a lot of power output. Not as much as 90 watts per meter, but 60 watts per meter. And that, with a perfect insulation, allows us to operate this type of lines even at ambient temperature, outside temperature, minus 20 degrees C, to reach 180 to 200 degrees C. The details here for clocking and for the other reasons, like we said, maybe the main task of the heated sample line will be condensation. So you have to make sure that your heater really ends here, not here, not here, not here, yeah, because then you have a cold spot, and depending on the environment where you do the measuring, a small cold spot can already be enough. I mean, if you pretend you connect here to the gas sampling probe, and then you have a piece like this, maybe 5 centimeter, 10 centimeter, that could be enough to give you a real headache in your measurement. So this is something, in any case, you should avoid, right? And yeah, therefore it's important that you have heater which supplies the same heat in every areas of your line. Doesn't matter if it's 10 meter, 5 meter, 100, 150 meters. Yeah, you have to make sure that this is heated in a proper way. And insulation material and the design of the heated sample line is very important. At the same time, you have to consider all advices, like Jemson showed in this example, no overlaying here. Yeah, this is something very important. And also when you do the installation, or when you, sometimes we prefabricate these type of lines, sometimes the line is finished, yeah, and the sampling, the probe side and the analyzer side is completely finished, so the line you will receive is ready to use. Sometimes we configure just one side and the other side can be finished on site, but you have to make sure that that you follow really the installation instructions. And if you use a quality heated sample line and you install this in the way of the installation guides, I think that should not give you a very big headache. At least that's what I think. Jemson, anything I've forgotten?
Well, I think sometimes people asking was that why our PT100 sensor, for the temperature controller, why are we putting 3 meter, right? Why not 2 meter? Why not 1 meter?
Yeah, good question. We are talking about this guy here, the PT100. Yeah, it's a difficult question, honestly, because the positioning of the PT100 is deciding about the temperature regulation and the controller temperature. And therefore,
because the reason was that some of the people, not just recently, I got a customer. They were asking, they have a big analyzer house. They have very big analyzer house, and after installation, we were in the midst of discussion. I assured him that our temperature control, our temperature sensor inside our heated line is 3 meter. The reason I explained to him that we want to ensure, all right, that the PT100 should be measured reference to the ambient temperature, not in the air-conditioned room. All right. So then we were checking because the analyzer house is so big, and they didn't realize that the temperature sensor is inside the house, inside the air-conditioned room.
Right.
So at the end,
you have to come to the coolest spot. That's what we always say. But this, in theory, is way more easy than it is finally at the practical situation. By the way, Jemson, 3
Yeah.
meter is our, let's say recommendation, but as manufacture all of these lines, feel free if someone says, okay, I need 2 meters or something. So this is something we can individualize based on the customer requirements. I just didn't want to miss to mention this.
That's right. That's right. This is what I told him to, in the future. I mean,
Okay.
they didn't tell us. I mean, this by standard, we
Yeah.
have a 3 meter length. Yeah. If they want a 5 meter, just mention and indicate to us in advance before we manufacture.
Right. We can do that. Oh, Jemson, now again, it's a complete mess, so to say. Why? The most complex topic, maybe the most complex topic here. We have 10 minutes left, right?
Yeah, for the cooler,
including the Q&A.
Yeah. Well, if I can answer all the Q&A even after the webinar. I would drop them. I'll reply them on the chat box.
Okay. Yeah, I think that's good. That's good. Jemson, how is that? Can you see all of this?
Yes. Now, in fact, the slides here is gas conditioning. This is another topic. I always say that this is the heart of the sample conditioning system. The heart, whether you have a strong heart or a weak heart, is really depending on the gas cooler, right? And many a times, particularly, many a times I saw a system integrator. They use one type of cooler, the one fits all. One size of shoe fits all. So this is something that's pretty dangerous, because in many times a good sampling system, many people have mistaken, they overlook, they use the mentality of a process sampling system. All right, they apply on the emission sampling system. Let me quickly say 2 things. All right, before the time's up. 2 things that you must be differentiate between a process sampling system and the emission sampling system. Number 1 is that between the sample probe to the gas cooler, between this distance, make sure, number 1, make sure that the sample is bringing the temperature above the acid dew point. Please make sure that you must be above the acid dew point. Number 2 mistake, and it's very common, but many people didn't realize, is between the pump and the gas analyzer. Between the pump and the gas analyzer, between the pump, they are pushing, there's a positive pressure. At this time, we must avoid back pressure. We must avoid back pressure. This back pressure will change the dew point, all right? And that will cause condensation, right? So therefore, how you regulate the flow meter is so important, all right? This is particularly for the commissioning engineer, right? These are the 2 points, please take note. Let's go back to the gas cooler, which is the heart of the sampling system.
Okay, maybe you can show one example, Jemson. I think we try to be not just in theory. I think your liquid carryover.
Okay, let me explain about. I think maybe we can go into a live demonstration about your those.
Yeah, we can. Maybe first of all, just these guys, we will see more in detail in the next webinar in 2 weeks, when we talk about the ATEX and the ATEX environment and the ATEX topic. So, but Jemson, maybe you can start the video just as an example what can happen if the cooler was not. That's probably a good one. It's hard to see, right? So what does it indicate, Jemson? What shows it? What does it show to an expert like you are?
Yeah, in my opinion, there are 2 possibilities. There are a couple of possibilities. Two main possibility is that at the heated line, when the heated line that comes in, they say 180 degrees. All right, many a time they stop heating at the moment they enter the cabinet. All right, so leaving unheated naked tubing to the gas cooler, it could be 1 meter. All right, that defeats the main purpose of heating. All right. I mentioned again, it has to be above acid dew point. So the
Right.
condensation starts from there. So the gas cooler, why people buy so expensive? The gas cooler is to remove the hot gas in the shortest time, to chill it down to 3 degrees, to squash up the water. All right. So therefore, this is the first mistake that allows condensation happening just before entering the gas cooler. All right. Number two, the possibility is the sample pump. The sample pump, many people has oversized the sample pump without understanding the capacity of the gas cooler can undertake. This is another possible reason. All right. Therefore, it is important to take aware that depending on the gas cooler, after the gas cooler, are they connected in series or you connected in parallel? This is very important, all right, to prevent all this water carrying over.
Yeah, absolutely, absolutely. This is maybe something I can show here in live. James, let me see. The camera moves. Is this fine?
Yeah.
Or the cable is long enough. Yeah. Okay. Here we go. I think it's pretty good to see. Here we have one example of our MAK20, which is a cooler, which is, I would say, in 80%, 90% Jimson used for emission monitoring. And the big advantage here, can you see the display, Jimson?
Yes, absolutely. Yeah, wonderful.
Okay.
Yeah, good position.
I think it's probably good to see the features and to show the features here. So at all times, you do have an overview of the performance of the cooler. So here you see the temperature, and I think this was also something you mentioned in your presentation and in the open points or the points which can happen. So this indicates the outlet dew point. Okay, fair enough. It's not a dew point measurement. This is a measurement of the cooling, or meaning of the temperature of the cooling inside of the cooler. But this already gives you a lot of information. It is counting the hours of operations here, and it also indicates when service is needed. Yeah. And there is an alarm. So if you have the situation that the outlet dew point, or meaning the temperature of the cooler will have a problem, this information is shown at the display here. And at the same time, we will indicate this to the analyzer system, so that the sucking of the pump can be stopped. Allow me also to show some details here. This is actually the peristaltic pumps, the pumps from the SR25 peristaltic pumps from Gardner Denver Thomas. The details of this and how they work, how they operate, what the quality difference are, we will see when we have the experts from Gardner Denver Thomas here on board. But in this case, Jimson, like you see, this is now a cooler with 2 gas paths. So you could either put them in a row, then the connection, there would only be one connection, one inlet and one outlet, or in this configuration here, you can use every heat exchanger inside of the MAK10. And one big advantage is, and I would like to invite you to use this opportunity. In the MAK20, we are capable to integrate a gas sampling pump, to integrate a sample, a flow meter, to integrate a depth filter. So there's many options. And when you contact us regarding your sample handling system, we, especially Jensen, can help you to find the perfect sample gas, meaning the perfect configuration. So yeah, that's really what I wanted to show. And maybe Jensen, if we go back to your presentation, because I think there is, as usual, just 1 minute finally left. When we go back to your presentation, there is a very special offer we would like to give everyone who is participating here. So Jemson, if you go to the next slide, please.
Yes. Yeah.
This is just this is just the different options I mentioned, which we are capable of to integrate. And we cannot see the final slide or the next slide, Jimson. It's not working. No. Oh, there we go. Okay, this is the overview. I think it's 10 o'clock, so it's 1 hour. But yeah, our references, this is all good. But let's come to the final slide, because I think that's a very special offer. Tobias will host your Calendly link here, Jemson, on LinkedIn, so that it will be possible. And I think that's a very special offer. And we would be very happy that you guys make use out of this. Is a Calendly link. That means Jemson is sharing his calendar, and he will offer you a free session in order to help you with quick fixes on your sample handling and on your sample handling system. So really make use of this, let's say, offer. I would use it, Jemson.
Not you.
I still believe we should put a price tag on this. So no, I think it's you have a long experience there. I think you saw many problems, and sometimes the solution for your problems is the impact of your problems might be big. The solution of the problem might be easy. Sometimes could be something bigger. We don't know. But yeah, we would be very happy to give you an advice and help you in sharing our experience in this field.
So Jörg, are we going to post this on our LinkedIn so that the members?
Yeah.
Okay.
Yeah, we will. As a special offer, let's say, for the guys who are attending or the people who are following our LinkedIn website, I think this is the special service, and hope you are prepared to be very much booked, Jemson.
Oh, let's see how popular am I.
Or you are. Okay, Jemson, we run out of time. 2 minutes already over the time. Let me thank you. I really enjoyed this again. I think it's always great. Next time we talk about safety, I think that will be a lot of new information we are going to share there. So see you in 2 weeks, and wherever you are, just stay safe. I think that's the most important.
Yeah. Thank you so much. Yeah.
No, thank you, Jemson.
Thank you so much.
Take care. Bye-bye.
Bye-bye.